All right, so we talked a lot about this stuff in class today. I just have it up here because I want you to get a chance to see it. The real definition of a triangle is a polygon with three sides and is named by its vertices. So there's three of them. All right, we talked about the ways to classify triangles. Here's the name: no congruent sides, isosceles, at least two congruent sides, or scalene, isosceles, and then equilateral, three congruent sides. And how to classify triangles by angles is obtuse. One obtuse angle meaning greater than 90, right? One angle that is a 90-degree angle. Acute, all three angles are less than 90, and equal angular, which means that all three angles are congruent or equal. All right, and so we could actually do this problem, which I'm not going to have time to do, but the way you would tell that this problem right here, this angle was or could be classified, is you would do the distance formula, which we've already talked about. The distance between here and here, the distance between here and here, and the distance between here and here, and get all the numbers. If this distance was 6 and this distance was 6, then you would say that these two were isosceles. If this was 6, this was 6, and this was 6, then this would be, that's right, equilateral. See, I heard you say that. But we're not going to do this example. We also talked about interior angles, all right? And we talked about exterior angles, all right? And so this particular angle here and here and here would be the vertical angles with those angles there. So they may not constitute as exterior angles, but I count them as exterior because they're not inside the polygon shape of the triangle. Now here we have what's called the exterior angle theorem. Okay, the exterior angle theorem. Now we talked about exterior angles. So angle 1 here is an exterior angle. All right, the exterior angle theorem says the measure of an exterior angle of a triangle is equal to the sum of the non-adjacent interior angles. Okay, so here's the adjacent one. So this one can't play. It said non-adjacent. All right, so the ones that are non-adjacent are A and B. So what this says is angle 1 is equal to angle A plus angle B. So the angles furthest away from the exterior angle, you can look at it like that, not the one that's right next to it. You add those two up together and it equals this particular angle right here. Now we'll work some examples and we may come back to this. Well, we don't want to see that. Let's go ahead and work some of our examples. All right. First thing I want to do is talk about classifying my angles. I'm not going to work all of these, but this one tells me to classify angle by its sides. And so what do you notice about all three sides here? They're equal. So this one will be an equilateral. If it's spelled wrong, your fault, because I can't spell. Number 2, what do you notice about the sides here on number 2? Well, these two sides are congruent and this one is not. So two congruent sides are called isosceles. All right? And we're only talking about the sides of a triangle. Notice number 3 here. I have 5, 7, and 10. None of these are the same. None of these are congruent, so this would be a what? That's right, scalene. I heard you again. Now, notice number 4 is different. Does number 4 give me any number values, any numerical values at all? No. It gives me these little marks right here, which tell me that these two sides are congruent. So again, this one is what? Isosceles. That's right. All right. Any questions on that? Oh, wait. I can't hear you. Yeah, no questions now, buddy. Let's go back. Classify the triangle by its angles now. Okay. Now we're talking about the angles. Okay, so what do we notice here? I have one right angle, and so this triangle is called a right triangle. All right, I have 3 angles, and all 3 angles are less than 90. Notice that all 3 angles are less than 90 degrees, and so this one is called what I am, acute. This one here, I have two 40-degree angles and one 100-degree angle. What would this one be called? That's right, it would be called obtuse. Obtuse says you have at least one angle greater than 90 degrees. All right? And number 8 here, what would this one be? Should jump out at you. It is equiangular. Which brings up a point that I have not discussed yet. I said it in class, but one of the most important things about triangles is the sum of all angles in a triangle is 180 degrees. Super important. The sum of all the angles in a triangle is 180 degrees. I'm surprised I didn't have that on there earlier. And you could prove that with each one of these problems if you took the time to add up each one of the angles. All right, let's keep moving. Now, we're going to take those ideas and find stuff. Now, don't worry about the exclamation points. I believe whoever made these worksheets fell asleep at the factory that day or got drunk or something, and they forgot to put the degrees, and then they put the exclamation points, which means factorial in math. But I guarantee you, this is not talking about factorial. So whenever you see those, just imagine that they mean degrees. So they want us to find the value of x. Now, how would we find the value of x? Well, I know this angle is what? 90 degrees. I know that this angle is 35. So how do I find this? Well, I would take 90 plus 35, which is 125, and then I would subtract that from 180. Now, where did I get 180 from? I can't hear you. Just kidding. All three angles of a triangle add up to be 180. Okay? So x has to be 55, and in this case, it would be 55 degrees. All right? Same thing goes for number 10, but I'm going to go ahead and skip number 10. You can figure out number 10 with the time that you have to figure that out. Okay. What about number 11? Think about this for a second. I know that this angle is 90 degrees, which tells me that the rest of my angles that I have to add up to be 90 degrees. Does that make sense? All angles, all three equal 180 degrees. And if they all equal 180 degrees, 90 plus 90 is going to give me 180. But notice that these two have the same variable. That means these two are equal. So how would I figure out what x is? I would simply take 90 and divide it by 2. X equals 45 in this particular problem because 45 plus 45 is 90 and 90 plus 90 is 180. All right? So the problem helped me figure that out because both of those were the same. If they didn't have the same letter, it would be very hard or either impossible for me to figure out what the letters were. All right, let's keep moving. Find the value of y. Now, this is using that theorem that we talked about, that exterior angles theorem. All right? The exterior angles theorem said that this outside or exterior angle is equal to the sum or adding the two non-adjacent, so this one can't play, angles. So what's 70 plus 88? Angle y is 158 degrees because I added 70 plus 88, and that equals the exterior angle y there. All right, so think about this. I want to know this angle right here, okay? And I know this one is 90. So that means two ways we can figure this out. This angle and this angle have to add up to be this. But more importantly, what is this right here that we see? This is a straight line. A straight line always equals 180. So if this side is 90, what does that make this side? Y here equals 90. We don't have to know or use that property, we could use what we've already learned. However, if this one is 90, those two have to add up to be 90 because all three of them on the inside add up to be 180. So say you didn't catch that was a supplementary angle right there, or a straight angle, then you could say, I know that this one being 90, those two have to add up to be 90, even though I don't know what they are. Hopefully you understand what I'm saying. If not, ask me. All right, what are these two? 20 and 42. And the exterior angle, notice how it changes. It is not going to always look the same. Get it out of your mind, but you need to see that the angle on the outside is going to equal the non-adjacent angles in the triangle that are that are on the inside. So y in this case equals 62. All right? So that's very important. That's me using the exterior angles theorem. All right, with the time I have left, I'm going to run through some of these. Find the measure of the numbered angles, okay? If this one is 90 and this one is 30, then 90 plus 30 is 120. And you take that from 180, this one has to be 60 degrees. Now let's look at number 16. We need to find angles 1, 2, and 3 here. We just did one just like this one. If this one is 90 and this one is 30, then number 1 has to be 60. Okay, 60 and 30 make 90. Okay, you can look at it that way. If I know that both of those have to equal 90. But what about angle 2? We haven't talked much about angle 2 today, but angle 2 is actually a vertical angle here with 30. Vertical angles is something that we should always recognize whenever we see that X. So angle 2 has to be 30 degrees right off the bat. Okay, so if this one is 30 and this one is 70, how do we find out number 3? How do we find out number 3? Well, think about it. Number 3 and number 2, angle 2, and angle 70 degrees always add up to be 180. Forget all the rest of the picture. Those three angles add up to be 180. So if this one is 70, this one is 30, what does angle 3 have to be? 70 and 30 make 100, so this has to be 80. All right. Looking at the time that I have left, let me see what's on the last page. All right, let's kick it up one more notch. Number 17. We want to be able to find all of these angles right here. All right. So let's see if we can figure it out. This angle is 65. This one is 45. 65 and 45 make 110, which means angle 1 is 70 degrees. Why? Because all three of these angles add up to be 180. I know that about triangles, okay? Now, how do I figure out angle 2 and angle 3? Well, one way I notice is if this part is 70 and this part is 45, that's 115, right? And so all I got to do is do 115 minus 180, and I believe, or I hope, that's 65. So angle 2 is 65. Hopefully you understood what I just said. If not, talk to me in the morning. So if this one is 65 and this one is 20 degrees, then all I have to do is add those two together and get 85 and subtract that from 180, which I don't know what that is off the top of my head. So I go back to my old elementary math, you see. And that's 7, 10, 5, and that'll be a 95. So 95, 65, and 20. Now, I went through several examples. Hopefully you understand how to classify triangles by angles or by sides. You understand that all triangles add up, all the angles of a triangle add up to be 180 degrees. And that we talked about the exterior angle theorem. All right, the exterior angle theorem. So review those things or go back over them if you have any questions. I'm done.